Now we want to talk more on energy stored in a charge capacitor. Let's deliberate a little bit on it. Now a capacitor is charged so that it can store what? It can store electrical energy. From the definition, a capacitor is a device that stores energy. So when it is charged, what is it storing? It is storing electrical energy. Now, to charge it, we are doing work. The work done in charging a capacitor is the energy stored in the capacitor. Once you have charged the capacitor, it stores electric energy. And the work done in charging that capacitor is still the same thing as the energy stored in the capacitor. You can use equals to, you can use is. The same. The work done in charging a capacitor is the energy stored in the capacitor. Now, while the capacitor is being charged, its charge builds up from initial value of 0 to a final value Q. Like we have said, before you even charge the capacitor, the charge on each plate is 0. But when you can charge it to an extent, you can charge it to a certain value of Q. Now, and the potential difference across the plates before you started was 0. But when you now charge it, you now have a final value of V. Final potential difference of V. Now, during the charging of the capacitor, the average value of the potential difference is given by just the way you will calculate mean. You have two values, you add them up. Because you have only two values divided by 2, so you are given as 0 plus V over 2. Your initial potential difference across the plate was 0, and your final potential difference across the plate was V. And you are taking the average of value of this potential difference. So 0 plus V over 2, which is the same thing as 1 over 2 V, half V. Now, the work done in charging the capacitor through an average potential difference of 1 over 2V is now giving us this. We have earlier proved that electrical work done is equals to W equals to QV. Now substituting that V, not just as ordinary V, is now 1 over 2V, we arrive at this formula. So once again, the work done in charging the capacitor through an average potential difference of this is giving as this. So that is the formula for work done in charging a capacitor. Modifying it further from C is equals to Q over V, we arrive at this and this. So we have three formulas for electrical work done in charging a capacitor. Now once again, the work done in charging a capacitor is the energy stored in the capacitor. The work done in charging a capacitor is the energy stored in the capacitor. Now here on the board is a question under calculating the energy stored in a charged capacitor. Calculating the energy stored in a capacitor. It goes this way, say a capacitor of capacitance 5 microfarad. Let's quickly pick out the parameters. So the capacitance is giving us 5 microfarad. 5 microfarad. It says subjected to a potential difference of 1000 volts. That is to say, the potential difference is 1000 volts. I can put it in standard form, which would now be 10 raised to power 3 V. Now I say across its terminal, calculate the energy stored in the capacitor. Calculate the energy stored in the capacitor. Now, because of the only two parameters we have, what formula out of the three formula are we going to use in calculating the energy stored in the capacitor? Obviously, is W is equals to half CV squared. W is equals to half CV squared because of only the two parameters we are given. RCV squared. The other two formulas can still be used at other times based on the variables or the parameters given. Before we go ahead to plug in our value, note our potential difference is in the SI unit volt, but this capacitance of this capacitor is not in the SI unit. So let's quickly put it in the SI unit form so that it will align. And to do that, to convert microfarad to farad, you simply times by 10 raised to the power minus 6 times by 10 raised to the power minus 6, which will now be 5 times 10 raised to the power minus 6 farad. With that, we are good to go. Quickly, let's put it into the formula. W is now equals to 1 over 2, 1 over 2, 1 over 2. Our capacitance is times 5, 10 raised to the power minus 6 times 10 back 10 raised to the power TV squared. Now we are obviously putting a bracket here because V is carrying square. V is going with square. So this is the same thing as 1 over 2 times 5 times 10 raised to the power minus 6, because this is square. 10 raised to the power TV times 10 raised to the power TV twice. Then 10 raised to the power TV times 10 raised to the power TV will give us 10 raised to the power 6. And 10 raised to the power 6 times 10 raised to the power minus 6 will give us 10 raised to the power 0, which will be 1 over 2 times 5 times 10 raised to the power 0, which this will give us 1. So we are left with 1 over 2 times 5 times 1. 5 times 1 times 1, which is 5, divided by 2 will give us 2.5. We call what we are calculating for work done, energy stored in the capacitor. So the unit is joule. So for this question, the answer to this question, the energy stored in the capacitor will be 2.5 joules in the SI unit.
To end this topic, we want to talk about the application of capacitor. Because once again, there are those 4 things you need to make a simple circuit. But you can go ahead to start adding other components. And one component we are seeing is the capacitor. We have seen the definition. Now I want to see where we can apply this capacitor. One place you can see the application of capacitor in a circuit is one is in tuning a radio circuit. So for a radio circuit, you need a capacitor to tune it. Once again, one application is for tuning a radio circuit. Another one is ignition of motor vehicles. You use capacitor to ignite your motor vehicles. Another one is for smoothing rectified current from DC power supply. For smoothing rectified current from DC power supplies. Another one is elimination of sparks when a circuit containing inductance is suddenly open. Elimination of sparks when a circuit containing inductance is suddenly open. So you not just put a capacitor in a circuit. It has uses, it has application, and I'm just giving you 4 if I am correct. Next, we are going to want to talk about the component resistor. What is a resistor, and why will you attach a resistor to an electric circuit?